simple philosophy. Being environmentally friendly can still be exciting. With electric power, there are no gears or clutch. Hit the accelerator and the Blitz blasts away like a rocket. Rather than top speed, the acceleration is the real surprise. Electric motors deliver instant torque as you put your foot down. And although the gutsy roar of a petrol-powered sports car is missing, flying along so close to the road, with the open top and the whine of the electric motors behind you, the ride is still exhilarating. But performance is not enough for a car like this. It wouldn't be a sports car if it didn't turn heads, and the Blitz doesn't let you down in this department. Like many concept cars, the Blitz has had several incarnations, including the idea of incorporating a dock for a jet ski. However, the final working prototype does make some concessions to modern practicality. To achieve the most beneficial power-to-weight ratio, Bertone have used lightweight materials wherever possible. The chassis is constructed of steel tubes stabilised by glass fibre panels and epoxy resin. The body is made out of composite materials and the interior is carbon fibre. The result is a combined body and chassis weight of an incredibly low 420 kilos. That weight doesn't include the drive unit. Inside here are two 28-kilowatt electric motors, one for each rear driving wheel. Now, there's no mechanical differential. Instead, the car's electronics provide an electronic differential here, and that controls the different speeds that the wheels need to turn during cornering. The power for the motor comes from 12 12-volt lead-acid batteries, 6 stored on each side of the vehicle. Together, they can produce a top speed of around 120 kilometres an hour. On a full charge, the Blitz will run at top speed for around 30 to 40 minutes. And more sedate motoring almost doubles this range. Improving battery technology will not only increase operating range, but with further savings in weight, the car will have even more blistering performance. After all this hard work, though, what if the Blitz never goes into production? Well, Bertone aren't letting their research go to waste. They're aiming to break a world record. Maybe this child of Blitz should be called Thunderbolt, but the project is actually codenamed ZER, for Zero Emission Research. After months testing the concept in a wind tunnel and smoothing the shape with computer-aided design, Bertone is announcing what it hopes will be the fastest electric car ever. With a body weighing 980 kilograms and a drag coefficient of just 0.12, the ZER will be powered by 34 lead-acid batteries, which should push this car to around 360 kilometers an hour. Whether or not the record attempt is successful, Bertone will really have made an exciting contribution to the idea of a high-speed, low-emission and fun-filled ride into the future.
Up on Beyond 2000, we're going to duck for cover. It's a bizarre new experiment in air safety.
There are those among us with very simple tastes. They only want the best, and for them.
When low-flying aircraft like these come into contact with birds of a different feather, the results can be disastrous. Take a plane flying at 400 miles an hour. A bird weighing just 1 pound can smash into engine compressor blades and cockpit canopies with a force of around 7 tons. That's 17,000 times the bird's body weight. And that goes for chickens as well. It sounds a little crazy, but for the guys at the Energetic Materials Testing Center in New Mexico, slamming a subsonic supermarket chicken into an aircraft is actually the best way of testing new materials, like a helicopter windshield. We watched the tests and had Dr. Caroline West check out the results.
Explosive experiments carried out at this site allow scientists to determine which materials can withstand the impact of a bird flying foul. In this instance, the pilot would have survived, thanks to this Lexan plastic windscreen. But others in the past haven't been this fortunate.
2 weeks ago, right here in New Mexico, we had a rescue helicopter flying to pick up somebody who was having a heart attack, and they flew into a duck. And the duck actually came through the helicopter and hit one of the nurses on board and really injured her quite badly.
But this is just one in a range of explosive experiments sponsored by Sandia National Laboratories to test materials in ways never thought possible. While the results of explosions like these can be controlled by careful placement of charges and sequential firing, what happens within each blast is essentially uncontrolled. When an ordinary block of high explosive is detonated, it creates a spherical shockwave. But when charges of differing strengths are placed in strengthened metal containers or lenses, the result is a controlled wave of explosive force that's flat in one direction. By varying the explosive mix and the shape of the containing vessel, they're able to produce almost any kind of shockwave they want. That force is then applied to substances like powdered metal alloys, which under other circumstances wouldn't be compatible. The explosives prepared for this test are designed to blast a flat shockwave downwards. It acts a bit like a powerful sledgehammer, which slams into the powders with such tremendous force that it causes the molecules to join together. It's hard to believe that until a few minutes ago, this tough metal composite was just powder. The reaction has created an exciting new compound with a unique set of properties. Shock compression experiments have been aimed at producing room temperature superconductors. Titanium and aluminium react chemically under extreme shock to produce other exotic new alloys with applications in the aerospace industry, as well as super hard synthetic diamonds with a myriad of industrial applications. Well away from everything and everyone, for obvious reasons, this former US military defence facility is enjoying a new lease of life. Since the end of the Cold War, more and more peaceful applications are being found for its expertise. And needless to say, the proprietors of the local supermarkets are more than happy as well.
Oh, big one. It'll fly.
Let's take them all. That way we can have a barbecue afterward.
That's great.
Diced chicken, anyone?
Europe is launching into a new era of space travel. We'll have details after the break.
For the past few years, the launching of commercial satellites, that's of the communication, meteorological, Earth resources, global positioning variety, has been dominated by Europe with its Ariane 4 rocket. Oddly, although the shuttle is the biggest and most powerful rocket around, it isn't economically or logistically suited to the role of filling the big demand for commercial satellite launches. American rockets, only the aging Atlas, Delta, and Titan rockets have enabled the US to hold about a 39% slice of the market, with the Chinese Long March rocket and Russian Protons picking up the scraps. The Ariane Space Organization, with its Ariane 4, does between 50 and 60% of all commercial launches.
Well, now, Europe is poised to consolidate that lead with the next generation of Ariane rockets. This huge new launcher is called, appropriately enough, Ariane 5. This is the assembly plant for the main stage of the rocket, which, like its predecessor, Ariane 4, is the product of an extraordinary cooperative venture involving some 70 companies from 12 European nations.
The assembly plant, which is already being called Ariane City, is at Les Mureaux, near Paris. It covers some 5 hectares and has around 260,000 square meters of floor space. With the maiden flight of the big rocket in late 1995, various parts of the first few Ariane 5 rockets are coming together from aerospace companies all over Europe. One of the prime functions of the Les Mureaux plant is the construction of the huge stainless steel tank that comprises the bulk of the main stage. 2 fully automated welding machines with built-in X-ray testing facilities enable the plant to complete one fully equipped tank every 6 weeks. This tank, which will be amongst the first to fly, is being fitted with a 2-centimeter thick, specially formulated and expensive coating of PVC foam insulating material to keep the fuel that will eventually go inside, the liquid oxygen and liquid hydrogen, at temperatures of minus 190 and minus 250 degrees Celsius. On this industrial mock-up non-flying model, they're replacing the high-performance PVC insulation with ordinary foam plastic for a series of tests.
If the tests are successful, then this extremely common and also very cheap polystyrene foam could allow less of the expensive and special PVC foam to be used, thereby saving considerable expense, but more importantly, weight.
At any one time, 4 of the big first stages of the rocket will be being assembled here in the huge vehicle integration building, inside of which the French engineers like to point out you could fit the Arc de Triomphe. Ariane 5 will be able to lift almost 20 tons into low Earth orbit. In one step, that gives Europe the ability to fly humans into space and support them. And although their own astronauts won't be flying on Ariane 5 until the early part of the new century, the rocket was designed from the beginning to provide Europe with an independent manned spaceflight capability. The actual process of equipping the first stage with all of its fluid and electrical connections and mounting the various protective elements takes about 3 months from top to bottom. The bottom part of the rocket's main stage, which consists of the thrust frame to which the powerful Vulcan engine will be attached, is fitted here during the assembly process. The thrust frame is immensely strong, as it must transfer up to 120 tons of thrust created by the fuel burning in the main engine through to the body of the rocket for a period of 10 minutes. It's also put through a series of exhaustive vibration tests designed to place the engine under the same degree of stress it would experience during the liftoff and the 10 minutes of firing. The test facility incorporates an inverted Vulcan engine and the exhaust cone of a solid rocket booster, also upside down. The main engine's ability to be throttled back and controlled with great precision, and even stopped if necessary, is what makes it so important. Yet it's nowhere nearly as powerful as the 600 tons of brute force thrust provided by each of the 2 solid rocket boosters like this one that are strapped on either side of the launcher. And while they might look small by comparison to the main stage, they produce some 90% of the thrust that's necessary to lift the craft and send it into orbit. The disadvantage of solid rockets, though, is that once started, they're virtually impossible to throttle back or stop, and the chemical fuels they use are difficult and dangerous to handle and transport. Consequently, the final assembly and fueling of these boosters is done at the South American launch site at Kourou in French Guiana. All test firings of the solid rocket are also done there. Work on the vast new launch complex, which has been underway for several years, is nearing completion in many areas, in preparation for the start of real business. The first Ariane 5 flight is scheduled for October 1995, after which the launch program will be quickly expanded up to 8 Ariane 5s a year. Europe's new rocket will not only help satisfy the world's apparently insatiable hunger for more satellites, but should also keep it well ahead of the competition.
Mixing megabytes with moisture. Up next, we'll see why computers are about to reach new depths.
Washed up on a wasteland, the monuments of a once dominant race. Superseded by a new order of techno-pirates, denizens of the deep.
Useless? Most definitely. We all know that megabytes and moisture don't mix. So while most of us have been gunning our engines in readiness for a trip down the information superhighway, those who delve in the depths have been left in the dark ages, mostly still using pen and paper. Well, not anymore. Researchers at the Australian Institute of Marine Science have been testing the waters with this. It is, in fact, a personal computer, but it goes much deeper.
It's not your everyday office. Well, the view's better than most, but it's lacking in the usual office techno toys, and that's where the wet PC comes in. Created by marine technologist Bruce McDonald as a kind of laptop for divers, in this case, more of a tank top. These marine researchers are surveying coral and fish on the reef off Australia's magnetic island. Usually the only way to record the vital details is with waterproof pencil and paper. But the wet PC is bringing cyberspace to inner space. The miniature computer mounted on the scuba tank is connected to a display attached to the diver's mask. It's a tiny computer screen giving access to files of research information. But the real bonus is that divers can keep swimming while they work, tapping in or accessing data via a small keyboard that fits in one hand. The system seems straightforward, but Bruce's biggest challenge has been to create something more than just a waterlogged word processor. He's done that at the Institute workshop, where the modular housing is created and the electronics fine-tuned. The prototypes have come a long way since the first wet PC, which was a full-sized computer in a waterproof box. The setup has been streamlined into a series of circuit boards sandwiched together to create a purpose-built program.
That means that we can stack them straight in there on top of each other, and we can build a modular computer very rapidly from basic.
The circuit boards are specially sealed in the main module, which is pressurized to survive any depth. But it's not until you get down under that you discover the real revolution at your fingertips. The standard typewriter keyboard has been cast away, replaced by a chordic keyboard or chord board. Each finger rests on a button, and you access files by pressing chords or combinations.
Oh, it was great. It's a little disconcerting at first having the graphics in front of your eyes like that, but the good thing is you don't actually have to make a conscious effort to look for them because they're just there in your field of vision and you get used to it after a while. I can control the whole thing with these 7 keys, and it's just like playing a piano. It's a matter of combinations. For instance, if I push those 2 middle buttons together, I get a sight map of the area directly below me. Likewise, if I push the 2 buttons on the end together, I get a list of the fish that I can expect to see while I'm diving. So it's designed specifically for my needs.
For Bruce McDonald, the cord board is part of a new breed of mobile technology which renders standard hardware obsolete.
Well, down here, it's a very difficult environment to work in. And even something as sophisticated as this is about as useful as a drowned rat. This sort of hardware platform is going to provide the basis for a new generation of tools for studying and understanding the environment.
While the wet PC has already made a splash with marine scientists, it's hoped that every underwater worker, from Navy divers defusing mines to oil rig repairmen, will go online.
Here we go. Great, it's beautiful. The way things are at the moment, all the information you record down there has to be physically downloaded once you're back up here on deck. But of course, that's still much faster than having to transcribe everything, as you have to do with pen and paper. But in the not too distant future, you could have a wireless link so that all the data is transferred instantly to the computer. How are we looking? Good. Oh, yeah.
Eventually, the wet PC will have a navigation system so that even the novice divers won't get lost. And once you're logged on, there's no escaping the outside world. A simple mobile phone link means that you could email, or is that C-mail, messages back to shore. With all these capabilities, Bruce hopes the wet PC can have a dry run as an all-terrain terminal for any mobile use. Think about it, one-handed word processing as you scurry through the urban jungle. Or tapping out your thoughts as you trek cross-country. This convenient computing could broaden our working boundaries so we can take the plunge and leave the office for dust.
Okay, swimming with fish while accessing data is one thing, but what about turning your PC into a fish tank? Is it software? Is it hardware? Is it wetware? Maybe Simon can enlighten us as he indulges in some fish and silicone chips.
Anyone who knows what real fish food smells like and how much fun it is to clean an aquarium will be grateful for this new product. It's called L-Fish. It comes from that part of the computer world called A-Life, or artificial life, which has already given us virtual reality. Now it's mixing biology, evolution and silicon chips to deliver an electronic aquarium.
See that one with the spots, the puffer fish, that's a sort of a fat fish.
L-Fish isn't a screensaver. It eats up too much computer memory for that. Nor is it a simulation program like Sim Earth. It isn't really a game either, and there's no beginning or end.
In this way, we'll be able to model any kind of animal.
It is an incredibly sophisticated program that turns your computer into a fish tank. But you get some state-of-the-art genetic engineering for your money. And getting inhabitants for your new aquarium is much easier than carrying plastic bags home from the live fish shop. Load L-Fish onto your IBM-compatible computer and start breeding. You simply pick the parents from a library of fish, choosing whatever takes your fancy. The control box presents the fish's vital statistics and its name. The program automatically warns you of impending sterility or mutant offspring. Place the parents in an action box and then double-click the mouse. A genetic breeding program then takes place inside the computer, away from prying eyes. Depending on your computer power, within a few minutes, a brand new fish is born. But it still needs to be given life in order to swim. To animate a 3D fish for your new aquarium, the computer has to generate 256 different colour images of the fish, essentially a view from every direction. This takes a lot of computer power, about 14 megabytes of memory. The results, though, are quite extraordinary. Never before seen or even imagined fish swimming in your screen. 3D fish on a 2D screen. The aquarium can be changed around at any time. You can have different coloured water, introduce new plants. You can even turn the lights on and off in the tank, and even throw in a bit of fish food. There's also a library of fish from different parts of the world that you can choose from. Right, let's have a look at this fella here. So if breeding fish isn't your bag, dial up a part of the ocean and drop a line in. The computer then catches fish from that region and puts them into the tank. Animatech's next project tackles the hottest topic in genetic science, dinosaurs, of course. While Elfish offers stunning graphics and a relaxing aquarium for users, it doesn't account for predators or population density or changes in water temperature, and has a long way to go before it's truly realistic. But the design team are working at a marriage of simulation with animation to make the next generation Elfish a true ecosystem.
The first commercial application for this animation is for an educational computer program. But it's likely that these low-maintenance aquariums will be finding their way onto other screens soon, perhaps bringing to life that boring old television.
Can a computer help?
On the continent which is home to some of the world's most exotic animals, the lion is king. For these beautiful beasts are powerful predators. In 1898 East Africa, in what historians have called one of the most unique events in human history, 2 lions killed more than 130 laborers during the building of the Uganda Railroad line.
Stop.
Now, the gruesome story of these lions, one light in color and one dark, comes to the screen in the adventure thriller named for them, The Ghost and the Darkness, starring Val Kilmer and Michael Douglas.
These 2 male lions literally working together started to kill for the pleasure of it, and it's never been recorded before or since.
In addition to his starring role, Michael Douglas is co-producing the film with Stephen Ruther.
And it's based on a real story. The level of fear, the level of tension, and the scope of the adventure required Africa. Africa has a look, a feel, a smell, a color. You couldn't duplicate it.
It's a very tough country. It's very humbling and inspiring. Just driving to work every day was a thrill, sometimes having to wait for the rhino to get off the road, and sometimes they don't want to get off the road. So they just hang out.
To authentically capture the spirit of this deadly story using real lions, director Stephen Hopkins, whose credits include Judgment Night and Blown Away, will have to combine the powers of nature and visual effects technology. So filmmakers turn to Sony Pictures Imageworks in Culver City, California.
It's not completely locked down, which means we need to stabilize it a little bit.
Visual effects supervisor Tim McGovern, who won an Academy Award for his work on Total Recall, will design and oversee 125 effects shots for this film.
For Kenya, this is locked down. People go to the zoo and they see lions, they watch them walk back and forth. On Discovery Channel, you can see all kinds of footage of what lions really do in the wild. So people have a fairly good knowledge of how lions move and act. You need the real thing.
For safety reasons, the lions must be filmed separately from their cinematic victims. Later, lions and victims will be digitally combined or composited to create the deadly encounters on screen.
true. I built that myself.
But the process begins in Bodplass, South Africa, where McGovern's first challenge is to integrate real lions into the visual effects. 6 lion trainers work with 5 lions from France, Canada, and the United States, selected for their unique athletic abilities, disposition, and training.
Everybody stay calm. If anything happens with Roman, we have professionals that'll take care of him.
There are 2 basic types of lion training.
Okay, roll cameras.
For a scene requiring the lion to look ferocious, filmmakers employ circus or dominance training. Parisian trainer Terry Laportier dominates the lion to bring out the animal's ferocious side.
You have to be a little bit dominant to handle any lion. They have to respect you. They have to understand the fact that you are not food. So you will slap them or use your hand or a small stick or whatever that's necessary to just maintain the rules.
The second method of training, called meat training, is based on reward and is often used when a shot requires the lion to run on command.
Good boy. It's no different than us going to work for a check. They come to work for their meat.
For this scene, Canadian trainer Mike Hackenberg and Hollywood veteran Hubert Wells set up to lure 10-year-old Bongo out of the grass at full speed.
Can I have you back here? It's just where I know where everybody is.
Another trainer attaches a chicken to the end of a cable as bait. When the cable is yanked, the chicken goes flying. If all goes according to plan, Bongo will be close behind.
How was that, boys?
Even with all its challenges, getting the lions' performances on film is only half the picture.
Great.
To composite or combine shots of lions and victims, the camera moves must be perfectly matched. So Sony Pictures Imageworks developed one of the production's most innovative technologies, the stealth dolly. When filming separate elements for compositing, filmmakers generally use a computerized motion control camera, which can be pre-programmed to repeat precise camera moves. The stealth dolly takes this process a step further.
Rather than programming moves into it, it remembers what physical space it moved through and can play back that exact move again and again and again. This remembers what you do to it, as opposed to having to be told.
Every move the camera operator makes by hand, pan and tilt, zoom and focus, and lift and dolly, is stored by the computer for the next pass.
And we can then take that data and we can play that move back at that location several times. We can even pack up all the gear, take it to South Africa, and if we need to shoot 2 different parts of a scene in 2 different sides of the planet, we can do that too.
Faster and quieter than traditional motion control gear, the dolly makes many otherwise impossible attack shots a reality.
We made a move with Val Kilmer running away from the lion and actually climbing up the tree. And then we got the lion to do the same action. He was actually chasing a chicken on a string through the shot with the same exact move, following both of them. Because the dolly was capable of getting the camera to be at exactly the same moment in the motion, the 2 things flawlessly go together.
Through the technological wizardry of visual effects and the riveting performances of ferocious felines, one of history's most unexplainable events is brought to the screen with frightening realism. When we return, the world's largest spider has Tim Allen running for his life.
This program is brought to you in part by Chrysler Corporation, where built
notorious for its prominent position among human phobias. For years, filmmakers have played mercilessly on this psychological fact in their push to keep audiences' adrenaline pumping.
As if 1,000 spiders were taking possession of her body.
In 1990, a deadly tarantula was unknowingly transported from the dense Amazon jungle to a sleepy California town in the chiller Arachnophobia. The spider wrangler on the film was Jules Sylvester.
These are the Therapursa leblondi, and they're found from the south of Venezuela into Guyana as well. They are the biggest species of spider in the world, and they've been known to get almost 11.5 inches across. That's from foot tip to foot tip. These ones are about 10.5.
In the film's climactic scene, Jeff Daniels' character faces his worst nightmare, falling into a dark, dank basement with hundreds of angry spiders. Some are mechanical, and some very real.
When he's actually looking for the spider on the shovel, I had a live one on a safety harness, and we swung the spider down off the pipes. Yahoo! Like that. It went down the handle to his hand, and he goes, ah! And then whaps the fake one into the electric box.
Now these mammoth tarantulas are making a comeback in the Tim Allen family comedy Jungle to Jungle, once again under Jules Sylvester's watchful eye.
It's a major character in the film. She is the pet of the boy from the jungle.